Hi there, welcome to video 5 of the integration topic at Higher. Today we're going to look at finding the area under a curve, specifically between the curve and the x-axis. Okay, so looking at what we need to be able to do today, we need to be able to identify and find the limits, identify or find the limits that bound the desired area, be able to set up a definite integral that evaluates this area, evaluate that definite integral to obtain the value, and be able to give the answer in context, ensuring the separate integrals are used where necessary. Okay, so having a look at that in a bit more detail, and then we'll revisit the success criteria at the end. Okay, now here we have a line, a curve, technically, a line y equals 2x plus 3. Okay, now in class with a bit more time, we'll probably go into a big investigation on this, but the thing here that's very interesting is that the area here, okay, the area that you find here is exactly the same as the integral between those limits, okay, between 2 and 4 of 2x plus 3 integrated with respect to x. Okay, so if we want to find the area there between the curve and the x-axis, it's the same, as equal to the value you get from your definite integral between those two things there. So if we want to find the area between the curve and the x-axis, that's what we need to do. We need to set up the integral and we need to evaluate that integral. Okay, so here looking at the examples, if I want to find that shaded area, and thanks to HSN for the examples, it might save me a lot of time, we need to integrate that curve. We need to set up an integral of x squared minus 4x integrated with respect to x, with the limits being the bounds of the area. So there it goes between 4 and 5. So we're going to do a definite integral of that curve between 4 and 5. So again, just in the last video, we're going to look at this and complete it. So x cubed over 3 minus 4x squared over 2 between 5 and 4. Okay, so that 4x squared over 2 will just become 2x squared. And we're good to go between our things. I'm going to move over here to give it a bit more space. Sorry for shooting about a bit. So it's going to be 5 cubed over 3. Take away 2 times 5 squared. Subtract the same thing, but with 4 instead of 5. Okay, and that there will give us our area. Okay, now I've just worked through that evaluation there rather than you watch me do my sums with fractions. It just take a bit of time as well, so follow through that, pause the video if you need to. It gives you the answer 7 over 3, and because we're talking about an area, we're going to call it 7 over 3 units squared. We don't know if it's centimetres or inches or whatever, so we're just going to call it 7 over 3 units squared. So the area in that is 7 over 3 units squared. Okay, now what I'm going to look at very quickly is what happens if I change the same curve but the area to underneath. Okay, so before I was looking between 4 and 5, now we're looking between 1 and 4. Okay, now just to shortcut this a little bit again, the integral is not going to change, we're doing the same thing. Okay, it will set up for x squared minus 4x between 1 and 4. Okay, it's going to give you the same integral, but this time we're looking between the limits of 1 and 4. Okay, so we'll substitute in 4 again. And we'll do the same thing this time afterwards, but with 1. So 1 cubed over 3 minus 2 times 1 squared. Okay, so we know the value for that first bracket. We get it from back here is negative 32 over 3. Okay, negative 32 over 3, and then we're going to subtract minus 5 over 3. Okay, now when you complete that calculation there, you can see it's going to be a negative 27 over 3 units squared. Okay, so there, that's this area here. They tell me it's negative 27 over 3 units squared. Okay, now clearly it can't be negative 27 over 3 units squared because it's an area that exists. You can't have a negative area. Okay, so what's actually happening here is because this is underneath the x-axis, it's going to give you a negative value. Okay, so we need to know and recognize the fact, okay, this area is underneath the x-axis, the value is going to be negative. The area here in this context is actually 27 over 3 units squared. Okay, so on top of being able to carry out the definite integral that will find you there, you need to recognize that, well, actually, this is going to give me a negative value, so I need to think about this and plan accordingly. Okay, which takes us to our final example. Okay, the difference here is we have two different areas. We've got one above the x-axis here and one below the x-axis there. Now that first area, we know if we run that through our definite integral, will give us a positive value. We also know because this smaller piece here is below the x-axis, it will give us a negative value. So if we were to complete that as one integral from -3 all the way up to 2, that smaller piece, that smaller area will actually cancel out some of the area on top and give us a false answer. So to complete this question fully and properly, we need to complete two different integrals. One between -3 and 1 because that bounds the upper area, the one above the x-axis, and another between 1 and 2 to get the negative value that we can turn positive and get a total area. Okay, so for this example, we're going to do two different integrals. The first one for the positive area, and again, just like always in half, feel free to signpost exactly what you're doing. So we know the positive area above the x-axis is going to be given by integrating this 3 minus 2x minus x squared with respect to x between the values of -3 and 1 where that area is above the x-axis. Okay, so integrating that is going to be 3x minus 2x squared over 2, so just minus x squared minus x cubed over 3, and that's going to be between 1 and -3. Okay, again I'm going to go over left, give me a bit of space, so substituting 1 first, it's going to be 3 times 1 minus 1 squared minus 1 cubed over 3. That's going to be your upper limit going in. Take away the same thing but with -3. So 3 times -3, subtract -3 squared minus -3 cubed divided by 3. Okay, I'm just going to pause the video and run through the answer for that. Give me 2 secs. Okay, so run through those calculations, evaluate them. So I'm just going to try and save a bit of time off this video, and that will give me 32 thirds units squared. So that is your positive area. Okay, now going into the same process, we're going to do exactly the same thing for our negative area. Okay, set up the integral again. It's going to be between 1 and 2 this time for 3 minus 2x minus x squared with respect to x. So the integral is not going to change. It's still going to be 3x minus x squared minus x cubed over 3, but this time it's between 1 and 2. So again, we go and we sub in our limits. So firstly, it's going to be 2 substituted in for everything. And then we're taking away the same thing, but for 1. And we know what to expect. We should be getting a negative answer because it's below the x-axis. Okay, again, I'm just going to run this through. Okay, and lo and behold, it gives us -7 over 3 units. Not units squared, it's -7 over 3, which in this context means the area there is going to be 7 over 3 units squared. Okay, now what that means now is if I want to find that shaded area, then all I need to do is, after I've done my two different parts, total area is going to be, well, from the first area it's 32 over 3, from the second area it's 7 over 3, so in total the area there is units squared. Okay, now an interesting question for yourself might be, if I set up that integral, instead of doing it two separately, if I set it up to do 3 minus 2x minus x squared, but instead of doing it in two areas, if I did it from -3 all the way to 2, what would the answer be? Okay, and I'll leave that there. I'm not going to tell you. Go chat to your teacher, chat to your pals, and find out, see if you can figure out what it would be. Okay, so looking back at the success criteria, being able to identify and find the limits that bound his desired area. Really, in that video, we only work with the identify part. Okay, if you need to find them, it would be where it cut the x-axis, so y is equal to 0 and solve. Being able to set up the definite integral to evaluate its area, being able to evaluate that definite integral, and then given the answer in context, ensuring separate integrals used where necessary. So if it's underneath the x-axis, recognise that, and then turn your signs, and using separate integrals if necessary. Okay, thank you very much. In fact, I'll go back and give you the answer for those who've watched right to the end. So, as a wee bonus, okay, if it's 39 over 3 here for the total area, if you did that all together, this 7 over 3 would be negative. So the answer you'd get for that integral would be actually be 32 thirds take away 7 thirds, which would be 25 thirds units squared, which would be totally wrong because this area here would knock out some of this area here and you would get a false answer. Okay, that's like a little bit of bonus content there for you. Thank you.